In this video, I am going to be discussing with you halogenation. So this is also one of our addition reactions. If you look at the word halogenation, you should notice the word halogen, which implies that we're going to be adding a halogen in these reactions. So we have halogenation is the addition of a halogen to an alkene. Instead of hydrogen, like in hydrogenation, we now have halogenation where we are adding a halogen. And remember, our halogens normally are in atomic form, so they are diatomic molecules. So we will have Cl2, Br2, I2, or F2 reacting with some alkene. Now the reaction conditions are as follows. Firstly, you are going to have that your halogen is going to be dissolved in some non-polar solvent. And no water must be present during this reaction for the same reason as it should not be present in a hydrogenation reaction. If we have water present, we're going to instead have hydration taking place, and that is not what we want. This here is for interest's sake. Now, interesting to know as well, the reaction is spontaneous, so that means it can happen at room temperature. We are not going to need a catalyst, nor are we going to need to add heat or put our test tubes or whatever we are performing the reaction in the sun. It will take place on its own. So when you write this reaction out, unlike in your textbook, you don't need to write out any reaction conditions. You're just going to be drawing these arrows. So this is an example from your textbook. Before I get to that though, the general formula or general equation that will take place, an alkene will react with some halogen. So you're going to write where X is equal to Cl, or it might be Br, or it might be F, or it might be O, in order to form a haloalkane. So here we have ethene reacting specifically with bromine in order to form 1,2-dibromoethane. Okay, so it goes from being unsaturated to saturated, and according to USA, this is therefore an addition reaction, specifically halogenation. And again, grade 12s, all that happens is that this bond breaks, one of the bonds breaks, this one breaks as well, and we have bromine attaching to one of the carbons and the other bromine attaching to the other carbon, so that we end up with 1,2-dibromoethane. If we go to another example, so here's another example of halogenation from your textbook. A reminder once again, you don't need to write out these reaction conditions. The only type of reaction conditions we are interested in is a catalyst, if you have a catalyst present, if you have heat present, or if your reaction is taking place in sunlight. That's all that we are interested in. So you're going to see your textbook will explain different types of reaction conditions. The specifics we are interested in is catalysts, your heat, if we need to heat it up, or if we need to put it in the sunlight. And since we don't have a catalyst here, we don't need to put it over a heat source, and we don't need to put it in the sunlight. We just write out arrows. So here we have propane, because it contains 3 carbon atoms with a double bond. So this is actually a mistake, sorry guys. This, so corrected in your book, it should be propene. Okay, so we have propene with a double bond. It's an alkene. Is going to react with chlorine, Cl2, in order to form 1,2-dichloropropane. So basically what happens is that one of these 2 bonds breaks. We then have the bonds on each of our carbons available. Our chlorine bond breaks, one chlorine attaches here, and the other chlorine attaches on this side. So in the end, we have 1, 2, 3 carbons, prop. This is a halogen, right? So it's ane, propane. We have 2 chlorine atoms, one on the first carbon, one on the second carbon, so it's 1, 2. Di for 2 chlorine atoms, chloro for chlorine, and our name is therefore 1,2-dichloropropane. It's as simple as that, and this is halogenation because we are adding a halogen to an unsaturated organic compound.